is just kind of an overview of a test floor. So we have the RITdb infrastructure. There's a broker with some kind of application sitting on top of that broker. And then we have a client, could be any kind of client. And this is, say, a non-tester client, which has a broker and some kind of apps. Could be your PC on your desk, right? And then we have a tester, which has a RITdb client and maybe some RITdb apps sitting on the tester, or maybe some that are kind of sitting off the tester, like an edge appliance that's connected into the broker, right? So this is just a conceptualization of what a test floor might look like in a RITdb infrastructure. One of the key things I guess I should mention, and this helps isolate you from network issues, because the broker is within the test cell. So everything within the test cell is on one broker. If the rest of the network goes down, who cares? I can keep running up until the time I need something from off the tester, right? So it keeps everything, and it's very quick because the response time within the broker, within the test cell, is very fast. So I can do lots of things on the tester that maybe I can't do if I'm going off tester out to the network on the LAN and back. So the next thing is kind of showing you an example. So this is one where the RITdb client is not integrated into the OS, but it's kind of sitting with the OS. So there's this communication, and it could be bi-directional tester OS to RITdb client. In this case, is single direction. We're just pulling stuff out of the client. We can't tell the client to do anything in this case. I mean, we can't tell the tester OS to do anything. We're just pulling from the data. So it's an independent install. So here's an example of some stuff we've done, right? So if you were native in the tester, I would want a little bit more out of this system, but this is assuming it's a non-native RITdb client installation. So the independent, it's an independent install. It's not dependent on tester OS version. We have a sourcing client. The RITdb sourcing client handles the connection to the broker, handles the messaging support, handles the authentication of the client to the system, client configurations, and deals with actions where I'm asking, you know, send a RITdb action message to the tester. It handles publishing of the events or state in real time. We've got the real-time data log stream, so both wafer and unit data collection, wafer, strip, unit, whatever, publishing the RITdb data log stream. Equipment log, this is tester inventory, so we're able to collect the tester inventory and send it out. Now, when we do equipment logs, we actually send a RITdb container through the message. It's a very small container, so we typically just send the container itself through the message. File monitoring. So we have the ability to monitor a file and generate events whenever there's new file content. And then directory monitoring. So we have the ability to monitor a directory and notify when new files appear. Now, why did we do this bottom one where we're just notifying new files appear? Hey, if I do a tester diag, it's too big a file to send via message. I don't really want to use up my network bandwidth by sending files that way. I might tell it, hey, there's a new file, and I have some other process behind the scenes which goes and grabs the file off the tester and moves it somewhere. But doing that, I know it exists. I know the name of the file. I know when it appeared. So now I can align it with other events that are happening on the tester. So that's why you need this kind of directory monitoring kind of capability. Keep in mind, I guess I'm just going to say this. This is from a perspective of integrating RITdb on a legacy tester or on a tester where the vendor won't do it for you. Okay, so just a few features. So the client runs as a daemon on the tester. Typically, we set it up as a service. It's a little bit trickier to do this on a Windows tester. You can do it, but there's a little bit more work. It's not quite as robust as Linux service. But we're running it as a service. It connects to the broker, and the tester client's authenticated before it's granted access to the RITdb system. So we have a process where it connects to the broker. Once it's connected to the broker, it has to go through some authentication process to be able to connect to the system. Right. We have something called a node key. The node key is an identity for the tester. That node key has to be authenticated, basically, and it's basically tied to the serial ID of the tester. So we have to have these node keys created. We can create a node key on the fly, but you have limited access to the system unless you have an authenticated node key on the system. Okay. And of course, we could do public-private key stuff. Internally in TI, we haven't really done any encryption because we don't need it. We're all in an internal test floor, right? But it's kind of dependent on your situation. And then we have published custom events that are RITdb compliant. So we've done a lot of custom events that are converted. They're utilizing a RITdb topic structure, but a custom topic. And they're doing the CBOR bodies, but it's a custom body. And then we're using something that we call reflectors. Remember, I mentioned reflectors earlier today to convert those custom events into RITdb standards. So that's how we get through this. And it's actually given us a lot of flexibility because, you know, the standard before it was published was, yeah, maybe we do this, maybe we do that. Hey, now all we do is tweak the reflector. We're done. We're standard compliant again. So it makes it a little bit easier that way. So just kind of some of the things, we have equipment logs, and we produce an equipment log whenever a session starts, or in some cases on certain platforms when a program is loaded. So that's really, when do you produce an equipment log? You have to think about when is there an opportunity to change something in the tester, and that's the frequency by which you generate equipment logs. So it's kind of unique by platform, but you kind of have to sit and think, okay, if this tester was idle for this amount of time, maybe there was an opportunity for something to do something on the tester, install software, install whatever. I'm going to produce in a new equipment log at that time. RITdb data logs. So we're streaming a data log window with every touchdown. So if you do, let's say, by 16, then that window will include those 16 devices for that multi-site card. Okay? So it's not necessarily one unit at a time, it's one touchdown at a time. And touchdowns can be quite big. You know, some of these can get up to, you know, 100 sites per run, I mean, per touchdown. So, you know, that varies a bit. So session events. So this is we stream tester events as they happen. Think of these like session start or stop, lot start or stop, program load, unload, you know, different events like this that I call session events, things that are happening within the run. And then we have test events. So stream test events as they happen. Test start and stop, binning, alarms, you know, these types of events can get very detailed. So within the RITdb client, we have the ability to turn on or off those events being emitted through the client. Okay. And then file monitoring, we have through messaging, I can set up a new file monitor. So this is not something where I have to go to the tester and do it. I can, through a message, update the RITdb client config file and set up a new file monitor utilizing messages. And then once I release the new config file, the new file monitor starts. Same thing with directory monitoring. I can watch a directory, and via a message to update the config of the client, I can turn on or off a directory monitor. So what's the test event logging? So a tester client captures test events and then publishes the info as a RITdb event. So here, for example, test flow start and stop. Kind of hard to see, I guess. Over here in the flow, you can see here, there's a start test flow event. So whenever I fall into the start test flow, hey, I get a test flow start event, and I might get multiple attributes. Might be the part list, the site list, whatever it is that is related to this event. And I can have custom events here that are unique to my platform. Then we have bin event. So maybe when I reach to binning, I have a bin event, and in there I might push out, this is the parts, the sites, this is the bin that was resolved or dispositioned for the part, right? And so I might have an individual bin event. Now let's say I have the RITdb data log event. So this is the point where I publish the data log stream. So here I might push the data log. So I'm just trying to show how within this flow, within a single, you know, within a run and single insertions of a part, I can have events that are generated at each one of these steps, depending on the kind of the level that you want. Within the standard, we have the high level events, but which we expect to be admitted. But within the test flow, those are kind of, they're available to be admitted, but you can make your choice. So again, the RITdb system that we have collects the data, aggregates the events into RITdb containers, and then archives them in the MDIR. So the way we have it today is, let's say I have a single site device and I emit per touchdown. The archiver or the collector will collect the data into, let's say, 50 unit chunks and then push it into the MDIR. So I never would lose, I always have most of the data. So my potential for data loss when, let's say, a tester crashes is really small in terms of the number of units data that I might lose. Right? So the way we've designed it, because for example, we've got some where we have 1 million die per wafer. And if you have to wait till the end before the STDF gets written and then saved, you've lost all of that data. Who can afford to retest 1 million die per wafer if on the 900,000 die, it died, right? So the idea is, well, we want to ensure that we collect everything as robustly as possible, and the data is sharded. So I don't have one big giant STDF file with 1 million die in it. I have lots of tiny files that I can keep track of, and we keep track of how many files we have, which part it is, how many, what's the min and max part number in there, etc. So I know how many files I should have to make up a run, and I can join them together. But it's a lot easier to query 10 small files than one big giant one. It's also a lot easier to transfer 10 smaller files than one big giant one. So I think it helps to solve some of that file movement problem too. Here's an example of some events, just so that you guys can see. So here's the topic structure, as Mark mentioned. There's the identity. It tells us, the unique ID of the client. Here I have a RITdb data log is in the topic. I'm sending a window, and you can see that I've got my min part is 426, max part is 427, part count is 2. And I believe this is a dual site card. That's why you've got 2 parts. And then you'll see it's part of, so we got this unique key that tells us it's part of something. So this tells us which run that these units are part of. And then I've got the sort order. So this is the 224th touchdown, right? And then it's a type window. And here you'll see byte size of this. So my data's in this binary thing that in my logger tool, I don't translate and show because it would, muck up, just fill up my logger tool. Again, here's an example of just a standard event. So here I've got a device status testing info begins. So here I'm doing a test info. I can tell you which cell it's on. This is the date. This is the event, action, assignment event. And then there's some data here, which custom data for TI. But, I figure, knowing one die and one wafer in one random place is probably not going to be very helpful to you, but it's a die ID basically that is recorded. And over here you'll see, I guess I did the same thing, but this is just a second event, action assignment event that gives us some additional data. So again, you can see we've got lots of different events. These are the standard attributes are these at the top, right? And then there's drives crazy. And the items down here are kind of custom stuff. Okay. So RITdb events are classified categorized into classes. So here you can see if we look at events, we've come up with these classes of events. We call them an event class. So there's an event class attribute, gives you error, warning, emergency. Emergency would be an event where you want somebody to act upon immediately. It's not just an error, it's a fire. Attend to it now. So they're very rare events which are classified as emergency, but we needed the class to allow us to do that. Then you've got cell status, cell setup, run info, summary and progress. Key difference between summary and progress is a summary of everything that's happened so far, and a progress is the progress since the last time you saw something, right? So everybody wants it differently, so we ended up with 2 different classes. Actually, the run progress makes it easy to do a chart so that you can see how well you're doing relative to the past, whereas a run summary is a much more difficult thing to do that way. So, you know, they're both useful depending on what kind of reporting you want to do. Device status, so this is at a device level, so part level. And then your equipment status, this is for non-cell equipment. Let's say I wanted to send some event that gives you some notice about a load board or a contactor or something. And then a derived event, which is those computed events, right, where we take facts and can create a derived event. And a watermark, which is used for alignment of batch windows. And then MES is something we're playing with to send an MES event. So we can say, hey, a lot split, a lot combine, a lot log in, a lot log out, or I don't know what people call it. We call it log in and log out in TI, but I guess where you move into a step and then you move out of a step in your MES system. And then we have OEE states, and you'll see here we've got the different colors, and I think you saw on the chart I showed before, you know, gray, green, red, blue, orange, yellow. These are suggestions, not requirements really, but we've just highlighted this so that when we do a chart that people can easily see, hey, you know, am I productive or not productive? Is there a down situation, etc. And here you'll see that a little tool that we have. So up at the top, you'll see the name of the tool and the last event that was emitted. And then down here, it's that scrolling window that I'd showed you before. This is an older version of the tool, but without markers. But this just kind of shows you the status in a rolling window. So again, I just kind of wanted to show you guys some stuff on the data log. So we got a RITdb client publishes data log each touchdown. In the case, what we did is we created both a pre and postscript, and FYI, we did a postscript on the equipment log as well so that we could, you know, add to it before it gets sent and becomes immutable. Before it gets off it's immutable once you've sent it to the system, but while you're sitting on the tester during the generation of the file, I can tweak it as needed. So in the case of the data log, we have a pre and post script. Why pre and post? There's certain things that may happen at the beginning I need to do, and then I need to put some stuff in at the end. So these pre and post scripts are run. It allows me to add TI custom data to what the vendor produced for me. And then the data log messages are handled by the system and can transfer the data as needed to support customization. The data log topic is monitored, collected into larger chunks, and then pushed into the MDIR. So here's an example. You can see over here, it's kind of hard to see, but you can see there's a window, and here you can see this number, 6, 7, 16, 8, 9. That's kind of which window it is. And you know, it's mixed, so I've got multiple testers coming out at once. So here's 5, 9, 5, 9. So these both tester 5 and 9 are producing data, and they have different windows that are being generated. And of course, this is all the data coming across. And you can see here, it's the timestamp as the data is being generated. So this is just a logger window where I'm just kind of showing you the fact that I can see events kind of popping across the screen. And you know, this, by the way, was from a factory over in Asia, and I was grabbing this data off my desk. So it's actually faster for me to connect from my desk than to VPN and do it from the computer, because the graphics are so slow coming back that it's faster for me to just look at it this way. Yes? Yes, those are two different touchdowns. Yeah. So this number right here that you see where it says RITdb data log / and then a number /, that's the, well, not really touchdown. You think of it as the window number, right? Yeah. So that increments. Well, actually, this is what the message ID. But we match, in this case, when it's a data log window, the message ID and the window number kind of match up. Okay. But yeah, so we just keep getting these, and then you can basically, you could subscribe to a particular tester and monitor that and then do something to show graphics. You could subscribe to all testers. We do have a lookup of tester to platform, so you could say, oh, let me go look up which testers are for, say, 93K, and then I'm going to go monitor all of those, because you notice platform's not on the topic structure, so you kind of have to then know which testers you want to see. But our system, we do have, of course, all the testers are registered with the node key, and within the node key, there's lots of attributes about the tester you could use. And then we're building a kind of a tester to group kind of address book where you could have testers grouped any number of ways. So you, within our system, could go, look, I want testers from this group, and then subscribe to that, and then it would show you the reports. So there's things like that that have to be dealt with in the application. So I think that's the last slide. So like I say, we have RITdb data log per touchdown. The archiver collects them and then pushes them into the MDIR. When we go in using a tool in the MDIR, I could pull up any one of the part ofs that I want to, using the metadata, find the one of interest. Like I say, you can amend the metadata to put in information about how well this part did. You know, if you want to mark it as being more interesting than the other parts, you could. Okay? So that's some of the stuff we're playing with, is how do you identify that something's interesting and mark it, right? Yep. So that's the end of the kind of client overview. Any questions?
Questions at this point? We've run out of material.
So you speak of some of the tools that you have.
I want everybody on the line.
You've repeatedly spoken of the tools that you have, some software that's been developed as part of this. I mean, are you including that as part of the standard, or what's the, and if so, what's your licensing mechanism for that?
The translator tool is included with some source code, and Mark can answer to the rest.
Yeah, you can just talk to me. We ship a lot of this stuff as part of our product. So if you're one of our customers, it's there. We've had a lot of discussions with people. You know, we're pretty flexible on licensing it, but they're open source tools, so they're sort of as is, where is, and we're trying to decide if people want to pay for that. But right now, all of the stuff you see there is probably 10,000 lines of Java code total. So just contact me if you're interested. We'll work out something. We're not charging for it. It's a typical open source thing. If we were to charge for it, it'd be for support. But our goal here is actually to come up with an infrastructure that doesn't require any IT, you know, doesn't require any expertise outside of being a product engineer. And, you know, we've got a couple interns right now working on a JavaScript version. We're doing a version of the tools in JavaScript, so you could use like React or something like that to make your own dashboards. But, you know, we've got a couple interns doing that. You want that? No. I'll show you my interns, no problem. So yeah, the question on that is if somebody wants to play with some of this stuff, just contact me. My email's on the site at SEMI.
Okay, any other questions?
Anything?
What about the other versions that are available outside of Java? Are those also available for open source?
No, the C++ was written by Adventist, so I don't know that they would hand that out. But pretty much it was not that bad. We took examples. So an implementers meeting that we're going to have soon, follow-up workshop, will probably give you all the basics you need to put a client together pretty easily. Once you got familiar with RITdb, the development of the client went very quickly. The majority of work we did with Adventist was really around some of the subtleties of their platform. Yeah.
What she's trying to say is if you have a modern Linux, it'll be a lot easier.
Well, we didn't exactly move to Red Hat 7, so I mean, I don't know that I could be too.
Yeah, if you're using something that's
it
Red Hat 7 or later, then all of the open source tools for MQTT just run perfect. You know, all the libraries, everything. If you try to go back, and you know, a lot of legacy stuff does go back, and it gets substantially harder as we go back, and Yeah,
Well, that's great, except for the huge floors we have. That's not going to help, and so it's more like, what's your biggest fleet? Well, that's what you're
Yeah.
going to work on. So, but yeah, it's a good lesson in what the standard needs to do to help people make a whole floor RITdb. So, I think that's a good thing. Where someone has the opportunity to really have huge impact with the newer platforms, I think that's definitely a great way to go, because you'll learn so much that doing legacy, you figure out what are the parts of legacy are useful to me, and those are the ones I'm going to implement. Because you don't need everything. If you don't need to improve your yield from 97 to 98, then maybe there's other places in legacy that you do want to monitor, like, is the tester up or down, or this, maybe that's the minimal kind of thing that I want on my legacy tester. I don't need all the other stuff. I don't need data logs, right? If I only need basic events, that's a heck of a lot easier to implement than all of the other parts, right? So I think you can make choices.
The question there was about why not just roll it off in totally. We put a lot of effort to make this an overlay, so that it works independently. And the issue we run into on tests, I've got testers out there 25 years old, is that there are very few green fields in assembly and test. And so if we go in there and say, you've got to make the conversion, the answer is, someday, somewhere, somehow. If we go in and say, well, you're making a lot of little ad hoc things anyway, why don't you ad hoc on top of this? Then that's much more, we get better response on that. It's just being pragmatic.
But I can say it does start to open people's ideas, and the biggest challenge we have is slowing them down.
Yeah.
While we try to build the infrastructure robustness. So, because people start getting, oh, well, I can do that, and I can do, what about that? Like, yeah, all of those things are possible. Let's get the infrastructure in place first. So it can really start to trigger some ideas on how to use it, because it really does kind of open this plug and play kind of capability across your test floor. And that can be really exciting with all the features that you can do. Like, so much easier for me to interface with one system, and then you do 20 apps against it. I don't care. I'm giving you the data.
Yeah, the nice thing that we're seeing about just having it is it's much easier to write RITdb files than STDF files, trust me. And it's actually easy to append to them as you're going. So it's much easier, like if we wanted to add load board temperature, or maybe there's some sensors starting, the Proteotech time put sensors on your chip, is how do I log all this sensor information? We end up doing these generic text records, or we do these binary files, or we do a whole different stream. The thing we can do with RITdb is make that standard. And then I can tell you the query thing is just so nice. Sit there and write a SQL query and start pulling stuff out. There's Python notebooks, there's R, there's tons of tools out there. Once we get it in SQLite, there's tons of free tools. And so it's really powerful.
I will say one of the biggest challenges to get over first is making sure your IT security is comfortable with a broker in your environment. And that's the first thing to get over, that hurdle, so that you don't have that challenge, right? And, we were able to do it on the manufacturing side. There's still some other areas in TI where they're like, you can't have it. So we figured out alternate ways of dumping data into, let's say, an Oracle database for the things that people need in that other environment. Say, okay, go grab it from there. At subcons, you mean? We have not requested that yet. Although we kind of got them used to it because it became part of our standard software that we put on for programs. So I guess we're kind of getting them used to it in an alternate way. Now, the key question is how much data are they going to let you stream off, because they don't want you to see it. I mean, we've already had that challenge because of our old event system, and how much they don't want us to see what they're really doing on, it's really challenging to understand the STDF file coming from a subcon, because you have how did I have 500 more units than went into the run. So, like, you dumped them into the hander in a circular fashion or something. I don't know, but that can be challenging. So we will address that at some point. But our goal was to become really robust internally. The beautiful thing is, though, it's much easier to share once you get them to agree to it. It's a much easier process to share across, because you've got that whole encryption thing. And maybe we deal with it by agreeing on what to encrypt and not encrypt in the system.
The question had to do with putting this in a subcon. You know, there's a huge push right now for edge compute throughout all of the tester companies. And so we're all talking about having edge computers now. And as soon as you start talking that, we talk about how we're going to interconnect them. So I think, and are we going to use the cloud or not use the cloud? You know, we don't really do much cloud stuff because it's not that safe. But these are questions that are industry-wide. I think they're going to be dealt with. People are going to have to figure it out.
Yep. All right. Sounds very good. All right. Thanks, everybody.